Hello and welcome back to our next short video demo on some organic chemistry nomenclature. I'm going to work through a few examples of structures that are going beyond alkanes and branched alkanes, and they're starting to involve some non-carbon atoms. So let's take a look at this first example that I have here. So we have a couple of halogens. As we know, halogens should be named with the prefixes for the corresponding halogen atom. So we could have 1, 2, 3 chloro or 1, 2, 3 fluoro, and then the chloro and the fluoro would have the other number. So whether we go left to right or right to left on this compound, the numbering for the branches, for the chloro and the fluoro branches, are going to be the same. So then when that's the case, we defer to the alphabetically first group. So this is going to end up being called, let me get my pen going, we're going to have then 3 chloro, 6 fluoro, and then if we count our carbons, we'll see that there's 8 of them, so that is octane. All right, notice that both O's in fluorooctane are there, because if you hear me say it, fluorooctane, you can kind of hear both of the O's there. All right, moving on to our next example. We have a couple of other functional groups, as we call them, that are identified using prefixes only. We have an azido functional group and a nitro functional group, along with the iodo functional group. One kind of weird thing to keep in mind when it comes to iodo branches, you can see that the I for the iodine just kind of looks like a continuation of the line. So you got to make sure you see that white space. Sometimes students will misidentify that as a methyl group, but you know, it's a font issue. Just make sure you recognize iodo when you see it. All right, so we're going to go ahead and number this compound right to left, because my first branch here would be 2, or it would be 2 going in that direction, but then the presence of the iodo branch then means that we want to number right to left so we can get the lowest possible numbers overall. Okay, so then for this compound, we are going to write it out as 6 azido, 3 iodo, 2 nitro. So that takes care of all of those functional groups which are identified using their prefixes. And notice A comes before I, comes before N in the alphabetical ordering of the name. And then this chain has 1, 2, 3, 4, 5, 6, 7 carbons in it. So it's going to be called a heptane. All right, so 6 azido, 3 iodo, 2 nitro heptane. All right, moving on, let's take a look at our first example of a compound that has a double bond in it. So these are the alkenes, E-N-E. And the name of the game here is to give the lowest number possible to the alkene. So the double bond portion of the compound is going to take priority when it comes to how we name it in terms of a suffix, as well as how we number it. Okay, so the double bond here, right here, this double bond, it begins on carbon number 1 as we number the carbon chain right to left. So 1, 2, 3, 4, 5, 6. So I have a methyl group at 6 for this overall 7 carbon chain. So when we do this guy, we're going to have 6 methyl, and then at carbon 1 is where the double bond begins. So the double bond begins right on the very first carbon. So I have a 1 in there, and then we call it hept for the 7 carbon chains. That's an E there, H-E-P-T. And then instead of it being A-N-E, it's going to be E-N-E, because that's how we put the suffix in for double bonds. Now, there are always 2 ways to write out the name for things that have double bonds and triple bonds, as we'll see, and that has to do with where we locate the number that indicates where the double bond is. So an alternative name for this compound, and one that is perfectly acceptable, would be 6-methyl, so that part doesn't change. And then we start naming the main chain next, so I put in the hept. And then here I hyphenate inside the name with the number and the ENE ending. So the number can go before either the root name of the main chain or immediately after the root name and before the ENE ending. Both conventions are equally acceptable. Me personally, I kind of tend to put the number out in front of the root name. I think when I learned organic nomenclature, that was kind of the preferred style, but it seems to me nowadays the preferred style might actually be to put the number after the root name, but before the suffix. Either way, again, is perfectly acceptable. All right, so here we have an example of a compound with 2 double bonds. So I have my carbon chain, 1, 2, 3, 4, 5, 6, 7, 8. So I've got an oct here. And on carbon 2 and on carbon 4, I'm going to have the beginnings of my 2 double bonds. And then there's a methyl branch here also on carbon 4. So when we write this fellow out, it's going to be 4-methyl, and then the double bond locations are at 2 and 4. And this is overall an 8-carbon chain, OCT. And then it's called octadiene because we had 2 double bonds. A couple of things about the syntax here. All right, so I've put the numbers here in front of the root name. I've got a di prefix in front of the ene suffix to account for the 2 double bonds. And you'll also notice that I didn't call it octadiene. I put an A in there. And that largely is just due for kind of phonetic reasons. But if you think about this, what we really have here is we have an octane chain. And what I've done is I've dropped off this E and that N, and then I've added the appropriate ENE ending because I put that D in the middle of it. So this is just a spelling thing, don't get too caught up in it. But if you have that numerical indicating prefix like di or tri for a 2 double bonds or 3 double bonds, you're going to have to put in this A in the middle of the name after the root and before you put that di or tri, just so that it sounds better, essentially. Now, of course, we could name this compound in a different way where the 2 and the 4 here are inserted after the octa part, right? We could have put it right there between the A and the D. Next up. All right. So here I wanted to put this compound in because if you're not careful, you might just go, oh, well, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10 carbons long, and it's got this side chain. Oh, there's a double bond in the side chain. Nope. You need to include the double bond in the main chain of the compound, in the parent chain. So this chain is actually going to begin here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, when you do that, you end up with a carbon chain that's not as long as it could have been if you went that way. But it's important, to get the double bond into the name of the parent chain, into the parent chain. So then this compound is going to end up having the name of 3-propyl, 1-nonene. All right, so the carbon chain begins here. Off of carbon 3, there's a 3-carbon branch, so that's propyl. And then we have a total of 9 carbons. So 3-propyl, 1-nonene. And once again, the 1 here could be inserted right in there. Okay, either convention is equally acceptable. All right, let's get to an example here for a triple bond, an alkyne, Y-N-E. And the naming here is exactly what we were doing for the alkene. We want to identify the longest carbon chain, call that the parent chain, and now it needs to include the triple bond. So carbon 1 is going to be this guy right here, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons in the chain. It's important to keep in mind when you look at the triple bond, right, that's going to be drawn linearly because these carbons are sp hybridized, so they're linear. So there's a carbon right there. There's a carbon right there that we have to be able to account for. All right, so 1, 2, 3, 4, 5, 6. So on carbon 6 here, I'm going to have that methyl branch. So this is named 6-methyl-2-no-9. Okay, that Y is pronounced like it's an I, no 9. And of course, I could also call this 6-methyl-known-2-ine. All right. Again, I think I prefer to have the number out in front of the root name because then the pronunciation of the name just kind of flows better to me. So 6-methyl-2-nonine. The other convention, the second way, 6-methyl-known-2-ine, I feel like I'm interrupting my pronunciation by inserting that number. But, you do whichever way you prefer. And lastly here, I have a compound that has both a double and a triple bond. Whenever we have compounds that contain both an alkene and an alkyne, the ultimate ending is going to be the YNE ending, the YNE for the triple bond. This is kind of going in alphabetical order. So this compound is going to be called an ene, En for the double bond, ine, YNE for the triple bond. So they list the suffixes, the two suffixes, in alphabetical order after the root name. Okay, so we're going to call carbon 1 on this compound. We have to think about how we do that. We could go this direction, 1, 2, 3, 4, 5, 6, 7, or we could go this direction, 1, 2, so the double bond will be on 2, or the triple bond will be on 2. But the presence of this methyl branch means that we're going to want to number left to right so that we give the methyl branch the lowest number possible. Okay, if this methyl branch were not there, then we would number this left to right. You would give the priority to the double bond because the ENE ending comes alphabetically before the YNE ending. So again, only if the numbers would be identical going left to right and right to left for all the substituents would you defer to giving the ene the lower number. The presence of this methyl group means we number left to right because I want to get the methyl group a lower number. Since the ene would be 2 or the ine would be 2, that's a push. Now I care about the other branches. So the name of this compound here is now going to be 3-methyl 2-heptene. And now here, I've got no choice, but I've got to now insert the number for the triple bond into the middle of the name here. So I have my 5-ine. Okay. What you cannot do is you can't take this 5 and push it out front there. Okay, because the 5 modifies the triple bond, the YNE. So I have to put that 5 right in front of the YNE suffix. Okay, you'll also notice just one other little spelling issue. There could have been an E right here after the ENE at the end of the double bond suffix, but since the name is going to continue, we drop that E, insert the number indicating the location of the triple bond, and finish the name there. Again, kind of like the octadiene I showed you before, don't get too wrapped up in these kinds of spelling issues. If you wrote out an answer with an E here for an enine, I wouldn't mark it wrong on a quiz or a test, and I doubt many teachers would, but just so you know, that E does get dropped. Okay, so things that contain both a double and a triple bond become ene-ine. So 3-methyl-2-heptene, 5-ine. All right, hopefully these extra practice problems that I've solved out for you have been helpful. And you can go ahead and tackle some of the other practice sheets associated with naming compounds now that have functional groups, some basic functional groups, like all of these ones that we name using prefixes, all the halogens, plus azeto and nitro, as well as some new suffixes for ene, double bonds, and ine, triple bonds. All right, that's all for now.